Yeah, so hi everyone, and thanks for first of all, thanks for joining us in this Pi and AI event. So basically, we have collaborated with DeepLearning.AI to have this event. So today we will be having our event on implementation of ML model with Tensorflow Js. So before starting with this event, let us have an introduction from Andrew NG.
Hello, deep learners. I'm Andrew Ng, founder of DeepLearning.AI, and I'm excited to welcome you to our global deep learning community. I know that many of you are here today because you want to break into AI and build your career. I hope that being part of this community will help you to do so. To give you a proper welcome, I'd like to show you around the DeepLearning.AI offices and meet some of the teams so that you can see where it all happens.
Oh, hi, Andrew.
Do you want to tell our friends at Pine AI what you do at DeepLearning.AI?
Sure. Hi, everyone. I make articles and other media that help people learn about AI and help them understand the huge impact that AI is having in the world. Today, I'm putting together the next issue of The Batch, our weekly newsletter, and I'm looking for the biggest stories of the week to keep our readers informed.
What's been the most surprising thing you've run into working on The Batch?
How much is going on in this field? There's never a dull moment. You might think from the outside that machine learning engineers really understand everything about AI, but nobody understands everything about AI because this field is just coming to life right before my eyes as I put this thing together every week.
All right, I know you're really busy, so let's you get back to it.
Thanks. See you later.
Let's go meet Kian, who helped me create the deep learning specialization. He's working on an exciting new project. Hey Kian, so do you want to tell the people at Pine AI what you're working on?
Yes, sure. I'm leading a project called Workera, focusing on helping people get offers in AI and navigating their career by testing their skills, preparing for interviews and certifying them, as well as matching and referring them to good jobs in AI.
That's really cool. And what's the most exciting part of your day?
You know, the AI field is new, organizations and jobs are still misunderstood. So I'm excited to help people understand what different types of jobs exist in the field, what tasks they will work on, and what skills are needed to achieve those tasks.
That's really important work. Well, it's nice chatting. And now let's go chat to Hotel, who is on their product team.
Hey, Andrew.
Do you want to say hi to our friends at Pine AI and let them know what you're working on?
I would love to. Hi, everyone. I lead the product team in DeepLearning.AI, where we create AI education content accessible to people all around the world. People like you.
And what are you most excited about right now?
I am so excited to see our community grow and to see how eager people are to learn more about AI.
Thanks, also.
Thanks, Andrew.
So as you can see, our team is working hard to support you and help you learn. It's never been easier than before to break into AI. So if you want to build a career, you can leverage online resources available, including open source code, datasets, papers, and online courses like a deep learning specialization on Coursera. As part of this journey, I hope you get your hands dirty too. Don't be afraid of diving in to build your own project, or go ahead and try to replicate a research paper that you're excited about. One thing that I've seen help a lot of people succeed is if you can build a community or find a community of fellow deep learners you can meet with and study with on a regular basis. In fact, I hope that this Pine AI meetup that you're at right now will be a good place for you to meet these people. I hope you enjoyed the event today and that you learn a lot, both from the talks and from each other. And once again, Welcome to the DeepLearning.AI community.
Yeah, so it was really a nice introduction about this Pi and AI event from Andrew NG. So now we have our speaker as Kartikey sir. So yeah, sir, would you like to introduce yourself?
So yeah, thanks Pulkit for giving me invitation on talk on this topic, and I'm very fascinated about Tensorflow.js. Yeah, today we will not go very in depth kind of thing, but it's kind of fun with WebML, and I will introduce everything about. Basically, linear regression is kind of a thing where maximum of you or those who are just started with machine learning can know, but those who didn't know even about the machine learning just assume if anyone got into mathematics. So this equation y is equal to mx plus c, it is gone through everyone, those who are done the mathematics. So though if even if you didn't do the mathematics, I will also explain that, so keep chill. And yeah, let's get started. So first of all, who I am. So I'm a co-organizer at TensorFlow user group Chandigarh. I'm also founder at developer student community, and recently I'm become a student ambassador at Angel Hack. So yeah, let's get started. So TF.js, Tensorflow.js, basically what it is an open source library for machine learning and web JavaScript. And you can also contribute, and you just go to the GitHub, just search it Tensor TF.js, and you will get the whole repo. And if you want, you can also contribute in the open source project, because it's an open source project. Okay, next. So why I use TensorFlow.js, why it is different from others. So basically, we didn't need able to install anything in a very small project. I will explain you. I am just only using a CDN, that is a link, even without installing a single module of TensorFlow.js. Isn't it a cool? And it is very interactive, very easy to access to any, you can say, sensor like webcam and microphone that will be installed in our, you can say, desktop or a mobile phone. It is also privacy safe. Privacy is a very must part of thing in every, you can say, project. And I will show you the API layering of why privacy is very higher, and here latency is also good, you can say low. Why we need a low latency? That's why we can render, you can say, the immersive AR applications or experiences that will be seen in, you can see in the Snapchat kind of thing. And now the main thing, JavaScript native, where we can also use this in our mobile application and desktop application. So yeah, let's get started. Use ML anywhere. JavaScript can run in anywhere, like browser, server end. It is uses Node.js. I will explain a little bit about it, how it is using Node.js, desktop, mobile, IoT. If anyone wants, if anyone here the Android developer, he or she knows, like if we use, if we make a like a simple HTML file, we can also run that file into a mobile application by using a web view feature that is involved in, you can say, in if you are developing an Android apps kind of thing. So yeah, in browser it supports Google Chrome, obviously, because it's a Google product, Safari and Firefox. And server and Node.js is working. In mobile, we can use React Native, WeChat, and PWA. Is anywhere, if those who didn't know about PWA, I'm just giving, it's a basically a part of a web application, progressive web application. It is an enhanced part of, you can say, web app, you can say. Desktop, in desktop, Electron framework is there. So you can see this if you want to like search on the frameworks. And IoT, as always, Raspberry Pi is the only, you can say the most fascinating sensors, or you can say model that will be used in the industry. So yeah, run, retrain, and write. What does mean actually? So in TensorFlow.js, pre-existing models are there. It is, but you also created your, you can also create your own model too. And if you want to update that model for that, you can say, for the sake of your problem statement, you can say, or the project idea that you are building. So you can also freeze that neuron, and after that you can retrain it. So sorry, so main thing, okay, so why I'm going in depth of, you can see, the layering, because I want you can understand everything, like what TensorFlow.js is doing. Okay, so yeah, Deepak, right? Transfer learning, yeah, basically transfer learning, yeah, cool. So what is the feature? Just I'm using the pointer, that's why like you can able to understand. So first layer is model, like you can take any model from TensorFlow Hub, if anyone knows TensorFlow Hub. Second is behind this layer API, And layer API, basically, if you heard about Keras, if anyone like done a Keras part in Python, so he or she can know like what I'm saying. Basically, it works on the DevOps kind of thing. In the privacy part, as I said, because they are totally dependent upon the client and server side. In client, as you know, CPU, WebGL, WebSM, same with Node.js, TF CPU and TF GPU. Um, as always, like TensorFlow Js didn't able to install anything. It just take all input from your cloud. Just you need to an access to internet, nothing else. Okay, and after that, at the backend, you can say the core TF.js converter is just directly converting the Python script into the TensorFlow file in the TensorFlow JavaScript, you can say. Okay, okay, yeah, let's get more into it. Large collection of pre-trained models, so you can go tensorflow.org.js model here, or some more like some model source from MediaPipe NLX perception that is available on TF Hub. If you remember, there is a blog came in from TensorFlow like MediaPipe and TensorFlow.js collaborated and make a face meshing model in which your all the you can see the vertices of your all faces will be connected. So there's some kind of, you can say, model image classification, object detection, face landmark, and something like that. So yeah, why TensorFlow JS we have some common, because it's why it is downloaded in many growth way, because it is used everywhere. Because JavaScript is used in web, and web almost used by each and every person, you can say, in the planet. Okay, so there is a very in-depth feature of WebML. So basically, I'm just working on what linear regression model is. So if those who didn't know about don't be scared of, you can say, if those who didn't know about the mathematics, don't be scared. I'm just explaining each and everything on that part. For instance, those who know like y is equal to mx plus c is the same, basically a linear line or a line that is made up of this parameter, you can say. So in parameter m and c, we are working on the m and c. But if those who didn't know about at all about very like a line defining kind of thing, so they can search it out also. It is very basic thing. You can just read it out and you can explain that. Okay, so what libraries I am using here? As I already said, I am using CDN. I'm not able to install, I'm even not install any single module of TensorFlow.js. I'm just using a script line that is like TensorFlow CDN. Then I am using p5.js because it make me very simple to explain you everything. And you can also check out the documentation of pf5.js, those who didn't know about pf5.js. Now, so there is a Smith, a great data scientist, somewhere between some simple linear regression, deep neural network. He grew up to as a data scientist. So yeah, let's jump into the code. And what I am doing, just I'm giving you a simple basic step. First, we create an HTML file and JavaScript file. I am adding CDN, or you can say the script link to the HTML file, link the JavaScript with the HTML file, and directly jump into the linear regression model. So I will just give me a second. I will show you the code, and we will walk through that code. Give me a moment. Give me a second. If anyone got any doubt till now, you can comment down in the comment section. And yeah, is my screen is visible?
Yes, sir, it's now visible.
Okay, yeah, great. So first of all, yeah, let's first of all, no, sorry for that moment. Give me a first of all, I will show you what our code is doing. So give me a moment for that. Okay, so I'm just sharing one of my window. First of all, give me a sec. Yep. So I think it is available, and first of all, I'm just showing what just you have to already install your console. Refreshing it, I'm just refreshing it. So as I'm adding the data point, so it's just, you can say, optimizing its own, like I'm just adding some points, and it is optimized as a, you can say, the whole model. I am using the model here. Here is the SGD, that is stochastic gradient descent, and don't be afraid of, and don't if you get into the machine learning, you will get to know that what I'm saying, gradient descent. Basically, it is reducing the loss function, and that those parameters didn't able to like don't see that part, because it is kind of a, for those who are very good into the machine learning. So it is basically stabilizing. Like if I am just increasing data points here, so it is like optimizing whole data points according to the data points. So yeah, now let's deep dive into the code. I'm sharing the code, just give me a sec. Okay, yep. So I think the code is available. Okay, so first of all, what I'm doing, I'm just creating two variable. As I already say, what we are doing, y is equal to m into x plus b, or you can say c, whatever you, I am here writing b. So yep, sorry guys, yep. Hmm. So basically we are it is the basic you can say the linear regression equation. So what I'm doing, just creating two variable two values, you can say x and y well, and creating in an array. Okay, so for those, for the constant like m and b, because I have for m and b I have to tweaking the value in order to stabilize the whole model, that the line that is adjusting by as I adding the points, the whole line is adjusting. So for that m and b kind of a constant, we have to tweaking that part, and x and y will be the you can say the constant thing. So first for that what I'm doing, first of all I have to, for Java it is a kind of a JavaScript kind of thing. So what I'm doing here, I'm just adding the points in the, you can say, canvas. For creating canvas, I'm using you can say p5.js. I'm creating a function setup. In here I'm creating a canvas for 400 comma 400, and for m and b, for constant which I able to tweak, what I'm doing, just creating a tf.scalar random, and what it is and why it is like it is kind of a, you can say, discussion kind of thing. But for those who didn't understand this also, I'm just giving you a link. Give me a moment. tf.js API, and I'm sharing here. Yeah, let me share whole screen, that's better. Give me a moment. Yeah, I think so my whole screen is opening. And yeah, so first of all, let's focus on what, like, as I already said here. So like why I created tf.scalar and tf.variable kind of thing. So first of all, why because one here is the, you can say, in the numpy form, or you can say in integer form, but I have to create it into tensor. So for converting tensor, we will use tf.scalar random1. Why we use that? Because in API, because it is clear, as if I think so API section is visible to you. Pulkit, can you check it?
Yeah, sir, it's visible.
Great. So what I'm doing here, so I'm just creating you can say numpy array to convert into the, you can say, tensor. For that, tf.tensor, and the value that I have to convert into tensor, and that print that, like if I run, so basically it converting into that tensor. So why I'm using tensor, it's a kind of a discussion kind of thing. So this is not a topic of this session, but we will surely in the future we can do that. And yeah, simple as it is, you can refer this, and I'm just sharing the link with you all here in the comment section if you want. Okay, so okay, over p5, okay, p5.js. Okay, Deepak, just give me, like, it is not a topic of that, but I'm just using a framework. Like you just go p5.js and documentation, and you can see, like, I can like ping that too. Give me a moment. It is a kind of a framework that I always use for, you can say, it is very easy. Like my voice is not clear. Like
No, sir, it's clear. Maybe he would be having some network issues.
okay, and so actually, yeah, I will share the code. Don't take that issue. Like I'll share my GitHub profile, like GitHub project link for that. So don't be like yeah.
Sir, your voice is not clear. We are not able to hear you what you actually speaking. It's not at all clear. It's breaking.
Give me a moment. Like everyone has same issue.
I don't think so, because it's Clear for me.
Rest one, rest all. Like my voice is like in breaking, or it's clear with my connection. Maybe I like I'm not saying like it's my like your problem, but let me give me a moment for that concern. Give me a moment for that. Okay, so now my voice is clear, or it's still kind of a breaking.
It's clear now. It's very clear.
Okay, thank you. Yeah. So let's present with my whole entire screen again. Okay, great. So yeah, let's dive into the code. And so Vaishni, can you tell me like where you miss out, like where my voice is
Sir, when you
broken
start
for
that
that moment?
slow part.
Okay, yeah, sure. So like yeah, I'm just explaining. Sorry. Yeah. So I'm explaining here like what I'm doing giving you that description. For that, I'm using the API here, TensorFlow API, and I've shared the link with you in the comment section. You can check them out. So basically, what like if this is the NumPy array basically, so I have to convert all the things into tensors. So for converting the why I am converting that into tensor, that is another discussion as I already said. But for I'm just converting to tensor. Just remind in your mind that part. Okay, so this simple TF.tensor, and just the you can say you just pass that NumPy or like a function for that particular thing. If you have to convert the return value into the you can say into tensor. Okay. So they just follow this API and just whole process, and we will walk through the API only. So yeah, bear with me on that. So yeah, again, next what we are creating a function mouse pressed, in which I'm creating two variables x and y, in which it maps the coordinate of mouse x, that is the coordinate of like the x coordinate and y coordinate of that particular thing, from where it will start 0 to width and 0 to height. Same with 0 to 1 and 1 to 0. And why I'm just referencing the number 0 to 1, because if those who are done the machine learning, they know the if you're doing the like MNS modeling, or you can say fashion MNS data set, you already know we are shortening the whole data set into -1 to 1 or 0 to 1. So here I'm just giving like maximizing the value, or you can shortening the value from 0 to 1. So that's why I'm using 0 to 1. And height and width is the height and width for the canvas, that is 400 comma 400. Okay, so after that just what I'm doing here, like I'm just pushing the value of x into xval, that is that after mapping from x and y, I push the whole value to the xval, that is here xval and yval. Okay, I think so here till now it's clear. Like there is okay,
Yes, sir.
great. So now we are deep dive into the draw one. Okay. So in draw, what I'm doing, just for like don't see this one, because it is kind of I'm just using the how I'm managing the memory. I will tell you this later. But just focus on here. So just focus on what I'm doing here. Like I'm just creating a background 0 that is in black color. Stroke 255, that is basically the points which I'm using, that is in the white point. And stroke width, basically it is a density. Like if I suppose if I make it like 8 and save this. Okay, so let's see. You can see the another one. Yep. So density, I think so. Density will be increased here. Yeah, as you see, density will increases. So basically, stroke width is basically used for increasing your density, nothing else. It is like for every point for plotting. So what I'm doing here, I'm just creating a loop so that I can again and again. So for that, what I'm doing, I'm creating a loop from 0 to xval.length to I++. Same with I'm just updating that, like xval for 0 position, 0 to 1, 0 to width, with 0 to 1, height to 0. Just oppositing, just doing the thing what I'm doing here as it is, like here, initial term here, nothing else. Just I'm creating it a loop, so it is, I'm just using the I for that, the positioning, the array positioning, what I'm just push that xval, push that x and y into the xval here in the initial one. After that, what I'm doing, I'm creating line x basically uh, this line, I'm just creating a line x from ranging to, as always, 0 to 1, because here if you see this, this is the 0 point, you can say, like I am not able to write here, but here this is the just assume it is a coordinate system where I'm just this is the 0 and this is the endpoint will be the 1. So that's what I'm just ranging here, and I'm creating an array which consists of 0 and 1. Here I'm fixing the ranges of the particular model. Now I'm just printing that x1, x2, y1, y2 with the same map line x 0, 1, 0, 1, as you see here. Now, the main thing that is, it is just kind of a basic JavaScript framework I'm using. Now let's deep dive into the machine learning part. So yeah, for machine learning, there is I have to predict like the simple y is equal to xm plus b, basically y is equal to mx plus b. It is a kind of, I'm just putting any value of x and it will give a product, it will give me the output y. So for like the requirement ys, what I'm doing, I'm just using, you can say, just I am implementing this into the coding form, like x is into, like I will show you in the API section, you will got it clear. So like operation and yep, give me a moment. Yep, in operations, no, yeah, not here. Yeah, so as like for, if you want to add two tensors, you can write a dot add b and dot print. Same with if you want to subtract it, multiply it, or if you want to multiply it, so like a dot multiplied with b, kind of that stuff. Or you can also do tf dot mul a comma b. So for with the same reference, what I'm doing here, I'm just converting y is equal to mx plus b into this form, that is xs dot mul, that is multiply with m in dot add means plus b. Simple as it is. And I'm returning whole the value of xs to the. Now I'm creating a function loss. Those who done the machine learning stuff, they know we have to reduce the loss. For that, we have to find out the loss. What I am doing here, like, yeah, so for loss, just for that particular moment, I'm just what I'm doing, I'm just predicting the I just want, you can say, the loss of that. Like I have the y value and I have predicted the y value. So by making differences between them, I will got to know about that. Like if the minimum is if the, you can say, the difference is minimum, then my prediction is good. But if the difference between very large between my prediction one and the existing ys, then my model is not good for that particular problem, you can say. So what I'm doing, loss is equal to prediction minus label, that is y dash. You can assume that like the predicted one, what we predicted, and labels that we already know the y value, and squaring that and taking mean of it. So what I'm doing, again, I'm just converting this into the code, you can say, in the form of code, that prediction dot subtraction labels dot square dot mean, nothing else. I'm just doing what I'm just writing here, like type here, I'm just converting this into a form of code. After that, what we are doing, like now we are going to, you can say, publish the learning rate and optimizer. So for those who didn't know about what is learning rate, basically how you can say, with how much degree the curve will move, so that they got optimized good, you can say, a very good optimization after adding the data points, you can say. So for that, there is an optimizer, tf.train sgd. You can also see many, you can say, the optimizer. like optimizer. So like as I use tf.train.sgd, that is stochastic gradient descent. I can also prefer you can use Adam optimizer too. Like it is a very good optimizer. Like many of the, you can say, machine learning engineer uses this optimizer because it's a very, you can say, top class optimizer. So yeah, it depend, you can say, person to person, the like which optimizer prefer you. Okay. So as I said, I in general way we take 0.01 as a learning rate because it's a default kind of thing, you can say. Like after research, after many research, it is found out that 0.01 is a good, you can say, good value. And after that, like if you want to, you can like let's increase this like 0.2 suppose, and let's save it, and let's run this in our here. Let's see what. So like as it is like very fast. Now I will show you like what I'm saying, why I'm just changing the points. Like okay, now if I implement this into form of a, like suppose 0.01, same this. So it will take a time, but it will take a little time for that. Like as you see, it takes too much, like it takes so much time to adjust into a model, you can say. Okay, so that's the, you can say, the part of learning rate. And the optimizer basically it's you can say, you have to see the mathematics of this. So yeah, I will not going depth, I'm going not into the depth of that. Okay, so now the main thing, the draw thing, tf.tidy. And now what is this, you can say, what is this? So this is the count. Now the main part is came where we are just reducing the memory management. Here I'm doing the memory management. So tidy. So yeah, this is the memory, you can say the memory. So basically what is tf.tidy it's doing, it executed the provided function and just clean up the whole tensors. Who doesn't like if like sometime it's also be like GPU using those tensors that doesn't require anything, that is doing nothing, but it is created in the GPU and your system is heated. So for removing that kind of tensor, that kind of tensor that is useless. So for that, the a function tf.tidy is used here. So what, like I will show you, if suppose if I am just commenting down this, assume if I'm just removing that, for removing this, so what will happen? I will show you for a moment. Just give me a sec. Let's I save this, and as after saving, you will see there. Okay, sorry. I drop script.js 15. Give me a sec, folks. What I'm doing here. Okay, sorry. This is the constant ys. Okay, sorry. Yeah, if I'm just removing this, sorry, wrong commenting. So yeah, after that you will see this is the use of tensor. Before that, a tensor is constant. Before, like if I'm using like this, the value of tensor increased, and in some time, if I've just kept in 10 to 15 minutes, my system will get over to heat for that moment. So for reduce that, we are just disposing whole things here with the use of this, you can say tf dot dispose and tidy. Basically, we are just removing the memory for that particular thing. So I think so you got this kind of basic. And for those who like, for those who want to understand like at what is the, you can say, what the memory is used here, for that it's a simple kind of tf.memory. It is a function, so memory bracket dot num tensor. It will give the number of tensor that is particularly used. But like if I already said it is 5 and just it is running, but it is constant. It's now the tensor is constant. Only 5 tensor is required to run this particular kind of a model. The basic model it is. So yeah, and so this is the end. And yeah, thank you guys. And I hope so. I clear some kind of a like just give into an introduction of Tensorflow.js, what it is doing. And if you like, if you not understand anything, you can ping me though at that moment too.